Alright, so welcome back. We're going to do another word problem video on law of sines word problems. And this kind of information will carry over into law of cosines because a lot of these different types of problems in this unit will deal with navigation. They'll talk to you about north, south, east, and west. And so since a big deal of solving these problems is to make sure that you get a triangle and you have to draw the picture, we want to make sure that we're drawing it correctly when we're given this kind of information. And so if you're not looking for word problems dealing with navigation, then you could probably turn the video off, but if so, then let's keep going. So hopefully you know your directions: north, south, east, and west. If you don't, apparently the iPhone has a compass app that you could open up and see, what direction you're going. But other than that, that's north, south, east, and west, right? So you got all your different ways to say it. You got your never eat shredded wheat, never eat soggy waffles. I heard one kid say never eat sour watermelon. Nah, I don't know. But either way, hopefully you've got yourself north, south, east, and west, and you can draw that. And I'm going to use that I guess, as we move forward. So in these word problems that you're going to see today, you're going to see things like this. You're going to see north 30 degrees west, or south 70 degrees east, or north 62 degrees to the east. And so how would you draw that? So what I always tell everybody is draw your north, south, east, and west first, right? So get your north, south, east, and west going to help yourself out. North, south, east, and west. Okay? And so if something says north 30 degrees west, what we're going to do is we're actually going to start with north. So it's a little bit different than the way you've become accustomed to drawing angles. So we're going to start with north, right? And then we're going to go 30 degrees to the west. So that would be your 30 degrees there, okay? So you don't start at your normal initial side where it's the positive x-axis. You're just going to draw your north, south, east, and west, and you're going to make sure that it's coming from the vertical to the horizontal. So once again, there's my north, south, east, and west. We're going to start with south, and then we're going to go 70 degrees to the east. And so now that means this is 70 degrees, and we can use that to help us solve the problem. So north 62 degrees east. If you want to give it a shot on your own, go ahead. Hit pause on the video real quick, and then you can draw your north 62 degrees east. Alright, so hit pause now. Otherwise, spoiler alert, here you go. Right, here's north, here's east, and we're going to start north, and we're going to go 62 degrees to the east. So this guy's 62 degrees. So when you're drawing your pictures, sometimes you'll have to find, right, that angle that we've got, or sometimes you may have to know this part. So it's really important to know which angle or which direction we're going so that we can then find the appropriate angles when we need to, okay? And then we can label our picture correctly. All right, so that's all that means. South 70 degrees east, start south, go 70 degrees to the east, and we should be okay. All right, so here we go. We've got our first word problem. On a ship sailing north, a woman notices that a hotel on a shore has a bearing of north 20 degrees east. A little while out later, after having sailed 40 kilometers, she observes that the bearing of the hotel is now south 80 degrees east. How far is the ship from the hotel? Okay, and so this kind of stuff that you see, the north 20 degrees east, the south 80 degrees east, you usually see it in conjunction with the words bearing. All right, so we're going to try to draw a picture of this. So we're sailing north. So here's your, just so that everyone's keeping with me, north, south, east, west. I'm going to say that this is the ship. Hopefully that's okay with you. And the ship is sailing north in that direction. Okay. Next, it says that a woman notices that a hotel on a shore has a bearing of north 20 degrees east. So when I'm doing this, I actually don't even try to put a point for the hotel. All I do is I just make a small little, at this point here, I just make a small little north, south, east, and west. And we're going to go north 20 degrees to the east. So 20 degrees to the east seems like that. And all I'm going to do is I'm going to just draw a line on. So 20 degrees to the east. And I'll talk about why I do that in a second. Next, it says that after having sailed 40 kilometers, right, so let's just say, boom, this lady is really interested in this hotel and has a protractor or something that's helping her figure it out. I guess protractor wouldn't really work when you're in 3D, but whatever. Maybe she's got like a augmented reality app on her new iPhone 10 or something. But north 20 degrees east was what she was at, but after sailing 40 kilometers, right, now she can see the hotel at south. So I'm going to draw once again my north, south, east, and west. South is down here, and she's going 80 degrees to the east. So 80 degrees, and then she still sees the hotel at that angle. So this would be 80 degrees to the east. And so the hotel, right, is going to be where these two intersect. So this is apparently where the hotel is. Yes, that's where her hotel is. Or I don't know if it's her hotel, but nonetheless, that's the hotel that she's got. Okay, so hopefully that made sense, the way in which it was drawn. We don't want to come from a horizontal line. You're always going to come from either north or south, and then to the east or the west. And that's the way it's written. If it's switched, then I would switch it. Like if it was east and then 20 degrees to the north, then I would do it that way. But the way it's said to us is it starts with the north, so that's the direction I'm going to start with, and then 20 degrees to the east, and that's why I have the angle the way it is. Okay, but once you have that, we can define a variable. What are we trying to find? How far is the ship from the hotel? So the ship is here now, right? So how far is the ship to the hotel? That would be this guy, x. So let x be the distance to the hotel. Okay, and hopefully now that you've filled in all the information, you should be able to figure out enough pieces to figure out where the law of sines is going to come into play. So this is 80 degrees, and we should be able to set up law of sines to solve for it. So x over sine of 20 equals 40 over sine of 80. And then we're going to multiply by sine of 20, so x is going to equal 40 sine of 20 over sine of 80. And then we can put in our calculator and just make sure your calculator, once again, is in degrees. And so once that's good, you should get the same as me. X is approximately 13.89 kilometers. So we'd say the ship is 13.89 kilometers away from the hotel. Once again, if you've never seen these 6 steps, they're pretty basic, right? So my 6 steps of solving a word problem kind of go as follows. I've got number 1, I've got a picture that's helping me solve it. I mean, to solve these problems, if you don't have a picture, you're probably not going to get very far. Number 2, I've defined a variable so that people know when they look at my picture what x is standing for. And then I can use that variable in my equation. Number 3, show a little bit of work. Number 4, got my answer. Number 5, that's critical. And then we should make sense of our answer in getting a sentence. Okay, so let's do one more just so that you kind of feel comfortable with the whole north, south, east, west thing. So we've got another ship, all right, but this ship is encountering a lighthouse. How wonderful. All right, so a ship is sailing south. The navigator notices that the bearing of a lighthouse is south 30 degrees to the west. After sailing for 2 hours at 8 miles an hour, he observes that the bearing of the lighthouse is now north 25 degrees west. Find the distance from the lighthouse at the time of the second sighting. All right, so I'm going to draw my little north, south, east, west just so that you believe me, right? North, south, east, west. Okay, and so we are sailing south. A ship right here. That's my ship. Right at the first spot, sailing south. And so at that point up above, I am going to put myself a little north, south, east, west line. Okay, and so it says at that spot we're going to notice a lighthouse south 30 degrees to the west. So I'm going to go this direction, correct? Right, south 30 degrees to the west. So I'm here. I'm just going to draw a line, and this right here is my 30 degrees. Okay. And then I sail for 2 hours at 18 miles an hour. Fun math question. How far did you go? Hopefully you say. We'll say it together on the count of 3. Okay, ready? Ready? 1, 2, 3. 16 miles. Yay. So we went 16 miles. They don't tell us how far we went, but we can calculate it because 2 hours at 8 miles an hour, distance equals rate times time. Okay? And so now at this point, I'm going to do another north, south, east, west, but my bearing is now north 25 degrees west. So I'm going to start at the north, correct? I'm going to start at north and I'm going to go 25 degrees to the west. So there we have it. I'm going to call that 25. And where they intersect, that is the lighthouse. Okay. And so from there, we should have enough information to fill in the gaps and solve away. So we do need the opposite angle if we're going to use the law of sines, and we want to find the distance from the lighthouse at the time of the second sighting. So this would be our x, because this is the second sighting, right? Second spot. All right, so we're going to define our variable, let x be the distance of the ship to the lighthouse. Hopefully you're setting up law of sines. 30 plus 25 is 55, so subtracted from 180 would be 125 degrees. So I'm going to go with 16 over sine of 125 equals x over the sine of 30. That means x is going to equal, if I multiply by sine of 30 on both sides, x is going to equal 16 times the sine of 30 over the sine of 125. Put that into your calculator with the appropriate units of degrees, and you should find that you get x equals 9.77 miles. So the ship is 9.77 miles away from the lighthouse. Alright, so hopefully that makes sense on the navigation stuff. If you have any questions, let me know, and have a great day.